Hi, welcome to Unit 7, Lesson 4. This is our last lesson in our unit on probability. In the previous lesson, 7.3, we looked at compound independent events. So compound events meaning you had more than one event going on. So maybe you are rolling a die and spinning a spinner, or tossing a coin and drawing tiles from a bag, but you had more than one thing going on. So we're still looking at compound events, just like we did in 7.3, but now we'll look at dependent events. So where the results of one event affect the probability of different outcomes in the second event. So again, just to review, compound events just means we have more than one event occurring. But in this case, we'll be looking at dependent events, meaning that one event does affect the possible outcomes of another event. The key here will be you'll be doing things like drawing tiles from a bag or taking something out and then not putting it back. So let's say you've got a bag of candy and you draw one out and you don't put it back. You've now changed the contents of the bag, which means you've changed your probability calculations for any future draws from that bag. So those are dependent events. When you don't replace what you drew out the first time, you now are having an impact on the likelihood of any outcome from a future draw from that same bag or jar, whatever it is. So here is kind of our formula or our process for calculating the probability of dependent events. So when two events, we'll call one event A and one event B, are dependent, so they affect each other, the probability of both occurring is calculated as, remember we read this as the probability of A and B, so the probability of this happening and this happening, and we'll do the probability of A times the probability of B given A. In other words, the probability of B happening given that A is already happened. So we're saying that A affected B, but we're still multiplying just like we did before. Here's an example of how one event affects another. So in this bag here, we have 10 marbles, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 total marbles. Let's say that I draw out this striped marble. So I drew it out. So it's not in the bag anymore. And then on a future draw, instead of having 10 marbles in the bag, I would now just have 9. So when I write my probability in fraction form, my bottom number would be a 9 instead of a 10 like it was the first time. That's what makes those dependent events. Because if I draw a striped marble and then do not replace it, the probability of drawing a particular marble on the next draw is changed because that bottom number would drop down to 9. Okay, let's solve one of these. A jar contains 3 red, 5 green, 2 blue, and 6 yellow marbles. A marble is chosen at random from the jar. A second marble is chosen at random without replacing the first. That's key. What is the probability of choosing a blue followed by a yellow? So the probability of blue followed by yellow. Well, we had 3 red plus 5 green, that's 8, plus 2 blue is 10, plus 6 yellow would be 16. So on the first draw, there were 16 total marbles in the bag. We want the probability of choosing a blue on the first draw. There were 2 blue, so that's 2 out of 16 times. Then it said we did not replace the first one. So on the next draw, there are only 15 marbles in the bag. We're going to assume that we drew a blue on the first draw. Now we want to draw a yellow. There would be 6 yellows. And now we can simplify. 2 will go into itself once. 2 will go into 16 8 times. So 2 16ths becomes 1 out of 8. 3 will go into 6 twice. And 3 will go into 15 5 times. Now, when you're multiplying fractions, you can also simplify diagonally. I'm just going to show you that over here. So right now we have 1 over 8 times 2 over 5. I can do 2 goes into itself once, and 2 will go into 8 4 times, and then top times top, so 1 times 1, and bottom times bottom, so 4 times 5, and get 1 over 20. Now, if you're uncomfortable simplifying diagonally, if that makes it confusing for you, let's come back over here and just multiply the way we have it. So top times top would be 1 times 2, and bottom times bottom would be 8 times 5, and we have 2 over 40. But then that can simplify by 2 over 2, and 2 goes into itself once, and 2 goes into 40 20 times. So we still get 1 out of 20. So in this situation, the probability of selecting a blue and then a yellow would be 1 out of 20. Get the next one. An aquarium at a pet store contains 6 male goldfish and 4 female goldfish. You randomly select a fish from the tank and do not replace it. That makes these dependent events. A second fish is randomly selected. What is the probability that both fish selected were female? So we want the probability of getting female followed by another female. And we don't replace the first fish. So on the first selection, there were 6 male goldfish and 4 female goldfish. That's a total of 10 fish, and 4 of them were female. So on the first selection, the probability of selecting a female is 4 out of 10. Then we'll multiply that by the probability of getting a female on the second selection. We didn't replace the first one. That means now there's only 9 fish. Now, assuming that the first fish we drew was a female, instead of there being 4, there would now just be 3. Excuse me. So by selecting a female goldfish the first time and not putting it back, that changed our bottom number, but it also changed the number of female fish still in the aquarium. Now we can simplify. 2 goes into 4 twice. 2 will go into 10 5 times. 3 goes into itself once. 3 will go into 9 3 times. So now across the top, we have 2 times 1. And across the bottom, we have 5 times 3. So in this situation, the probability of getting a female fish both times is 2 out of 15. Okay, the next one. A cooler contains 7 orange drink boxes, 3 fruit punch juice boxes, and 2 apple juice boxes. Sammy is going to randomly select one juice box and not replace it. Then Johnny is going to randomly select a juice box. What is the probability of an orange juice box being drawn first and then a fruit punch juice box? Okay. So the probability that we would get orange followed by fruit punch. Well, let's see what was in the cooler. We had 7 orange, 3 fruit punch, 7 plus 3 is 10, and 2 apple juice. 10 plus 2 is 12. So there were 12 juice boxes. There were 7 of those that were orange. So on the first draw, there's a 7 out of 12 chance that we would get an orange drink. Now on the next draw, since we didn't replace the first, there are now only 11 juice boxes in the cooler. And we want to select a fruit punch second. And all 3 fruit punches would still be there because we're assuming that we drew orange the first time. Now remember, we can simplify diagonally here. 3 goes into itself once and 3 goes into 12 4 times. And now on the top, we have 7 times 1. And on the bottom, we have 4 times 11. So in this situation, the probability of selecting orange, not putting it back, and then getting fruit punch is 7 out of 44. Okay, last example. Slips of paper numbered 1 through 15 are placed in a box. 2 numbers are drawn randomly, 1 at a time, without replacement. What is the probability of selecting a 7 and then a 2? So the probability of selecting a 7 followed by a 2. Well, there are 15 slips of paper. So on the first draw, all 15 are there. Only one of those is a 7. Then we'll multiply that by the probability of getting a 2. Since we didn't replace the 7, now there are only 14 slips of paper in the box, and only one of them is a 2. So the probability of getting a 2 on the second draw is 1 out of 14. Now we'll do top times top, so 1 times 1. And then we have 15 times 14 on the bottom. 4 times 5 is 20. 4 times 1 is 4 plus 2 is 6. 0 over. 1 times 5 is 5, and 1 times 1 is 1. And that gives us 210. So the probability of selecting a 7 followed by a 2 is 1 out of 210. In other words, not very likely. And that would be the case with any combination of 2 numbers. Because in this situation, there are so many different things that can happen, the probability of each individual thing happening is really slim. So that is it for probability of compound dependent events. Again, the key things to remember here are that you're simply multiplying the probability of each separate event, but you have to keep in mind that if you don't replace something, you're changing the bottom number on your next probability. So just keep that in mind, kind of be aware of what you're being asked and how the situation is set up. Is it being replaced or is it not being replaced? If you have questions, please ask those. If you're ready for your skill check to be open, let me know. Thanks and have a fantastic day.